Okay, so we're going over the intersection of linear and quadratic systems. So essentially what we're looking for is we have our graph here. We're looking for the intersection points of this linear equation and this quadratic equation. We quickly made them up. This is the standard form. We had to kind of work backwards from vertex form. So I'm assuming we did the calculations right. This is our standard form of the quadratic equation, and this is the linear equation. We're looking for when they're essentially equal to each other. Okay, that's what they're telling us. So what they would say is tell us when, for instance, we usually use set notation. So maybe this would be considered our f at x. Let's move that out of here. And this would be our g at x. So in other words, we want to know when f at x is equal to g at x. When do they cross each other? That's the points. So we're going to scroll down a little because I want to write the equations out. What we're looking for is when negative 2x squared plus 24x, this is our f at x, minus 67 is equal to 2x minus 9. Okay, that's where we're getting this f at x minus g at x. See where the equal sign goes right above? This is our g at x equation, right? This is our g at x from above. And this is our f at x from above. Okay? Super loud. So what we're going to do is we're actually going to find, or we're going to derive them in order to figure out where they cross each other. Now here are the 2 points we can see on the graph. We actually have to find those points of intersections, or especially what their x values are, and then we'll find the y values from there. So we take this equation, okay, the negative 2x squared plus 24x minus 67 is equal to 2x minus 9, okay? And what I'm going to do is I'm going to set it equal to 0. Setting it equal to 0 will help me find the points of intersection, okay? Just like they've kind of done here. They put these two together, we're going to set it equal to 0. So let's find these points of intersection. When I move these to the other side of the equation, we get negative 2x squared plus 24x minus 67 minus 2x plus 9 is equal to 0. The reason we set it equal to 0 is because we can then factor. Okay? We always want to set things equal to 0. We're going to collect our like terms. Our like terms are the 24 and the negative 2 and the negative 67 and the positive 9, right? So we collect those 2 like terms. We'll get negative 2x squared. 24x minus 2x is going to give us positive 22x. And negative 67 plus 9 is going to give us 58, negative 58, okay, which is equal to 0. I'm going to look at this. I can probably try going through the factors of this and factoring it. Might take me a while. One surefire method to solve this, do you know what the formula is called?
Quadratic.
Yeah, quadratic formula. So we're going to plug in the quadratic formula. In other words, x is equal to negative plus or minus the square root of, and then of course it's all going to be divided by, so I'll put that line in now, b squared minus 4ac, all divided by 2a. Okay, so quadratic formula, you remember this from before?
Yeah.
Okay, so our values, first of all, this is our a value, the negative 2. So in place of this a and this a, we'll be plugging that in. These are our b values, so the positive 22 will go in place of both of those. And these are the c values, negative 58.
Like, say for like if b wasn't
positive?
If b was also negative, and there's a negative in front of that, would it be just positive by itself?
It ends up being a positive. So I'll show that by plugging these in right now. So when we go to plug these in, we're going to get x is equal to negative, well, b is positive 22. Okay, so I'm going to plug it this way on purpose. The reason we put plus or minus in front of this is because it's a square root. And the square root, whenever we find the answer of a square root of something, we're going to get a positive and negative answer, right? For instance, the square root of 4 is positive 2 and negative 2. Our b value, again, when we go inside here, is positive 22 squared minus, and then 4 times, our a value is negative 2. And our c value is negative 58, okay? And here we get 2 times our a value again is negative 2, okay? So this is directly related. Do you see the negative beside the positive 22? What is that going to essentially become?
Negative.
Negative, right? And that makes sense. We plugged that negative in there. So if it had been another negative, it would have become a positive number in front. So x is equal to negative 22 plus or minus, and then we write the square root. Well, we're going to need a calculator for some of this because these numbers are going to get rather large. Okay, so 22 squared, 484. Okay, so that becomes 484. Now these are three negatives times each other. Okay, so this is negative 4 times negative 2 times negative 58, which gives us 464. Okay, works out okay. Minus 464. All of this will be divided by 2 times negative 2, which is
Negative 4.
good. Negative 4. We're going to try to jump a couple steps here. This becomes negative 22 plus or minus. This is going to be the root of 20. Okay, 484 minus 464 is a difference of 20. So we're looking root 20 divided by negative 4. Now I could root it, but here's the important part. I can technically split this at any time. Because it's a positive and a negative, that's also to remind us that we need to essentially split this question. We're going to get two answers. Okay, so our two answers in this question are going to be either option. So we're going to get x is equal to negative 22 plus the root of 20 divided by negative 4. And x is also equal to negative 22 minus the root of 20 divided by negative 4. We're going to find actual values. Some of your teachers might want you to keep these things in radical form, stuff like that. But we're going to find these actual values. So we're going to root 20.
How do you keep that in radical form?
Well, we could try taking out root 4, which would be, we can split this into two questions, right? Root 5 and root 4. And then root 4 is 2.
Oh.
And then because there's a 2 there and a 22 there, I can kind of divide both terms by 2. It would still have to be 3 terms, though. Okay? So it's a little easier if we write it as a decimal. Root 20 is 4.47, we'll say. Okay? So let's write these again. So x equals negative 22 plus 4.47. Is that what we said?
Mm-hmm.
Divide negative 4, and x is equal to negative 22 minus 4.47 divide negative 4. Okay? Let's go from there.
It would equal the same thing?
No, because this is a positive. Oh, yeah, root 20 will be the same thing. Root 20 is 4.47, and root 20 is still 4.07. One is positive, one is negative, though. That's the difference. So let's try to do these all in one shot. Negative 22 plus 4.47 equals 2, divided by negative 4. 4.38, that's our first answer. Okay, so that's the one on the left I just did. X equals 4.38. And in this version, we'll do it all in one step on the calculator here. Negative 22 minus 4.47 equals, divided by negative 4, 6.61. Okay? 6.61. So what we've discovered is the points of intersection are at an x value of 4.38 for one of them, and the other x value is at 6.61 for the other point. Okay? So I don't know if we can see this all on the entire page. Yeah, it's a little far. Let's zoom in again. Remember those terms. Remember what we said? What did we say? 4.38 and 6.1? Okay.
7. 6.17.
6.17. Okay, so my drawings aren't perfectly accurate, but they're fairly close. If we look at this point of intersection is a little bit after 4. It can be considered at 4.38, the x value of it. Okay, we don't know the y value yet. And the other point of intersection, what was it? 6.17, was it? Let's double check. 6.61. Okay. 6.61. Okay, that looks like it could be a little more than halfway over, right? Because there's a width to these pens, they're not exactly perfect, but they look like they make sense for what we've drawn. But all we have is the x value of both. we still need the y value for the exact point of intersection. So we now have to take that and we go down back to the equation we'd started with, this one here. I'm going to highlight it now. This equation is essentially the amalgamation of both of them. All right? So this equation here, we take those x values, one of them being, whoops, not what I wanted. One of them being x equals 4.38, and one of them being x equals 6.61. And we plug them in for the x values in this equation. Okay. Now I know we set it equal to 0, but essentially it could be also known as maybe our h at x, our new equation. Okay. So we find what x is at those points, and it'll tell us the y values. Okay. So I'll try to do my calculator in one shot. I'm not sure if I'll be able to pull it off. 4.38. Let me make sure that's the right number one more time. Yeah, 4.38. Okay. So 4.38. We have to square it, then multiply it by -2, then add 22 times something to it. Okay. So I guess we'll try to